Okay, algebra, this is section 9.3. This is the last section of chapter 9 that we're actually going to do. There are more than this, but this is usually all that I teach out of the trig chapter for my Algebra 2 class. So tomorrow, not tomorrow, a couple days from now, I will give you, or my sub will give you the review for chapter 9, and we'll be done with the chapter already. So section 9.3 kind of combines what we found from 9.1, which was SOHCAHTOA stuff. So we did like sine, cosine, tangent, and we're going to use that in this section. So remember that. And then in section 9.2, where we talked about like angles that are rotating around in a coordinate plane, we're going to combine both of those things together, okay, in section 9.3. So this isn't really too much new information. It's just combining the two things. So in example 1, I'm going to jump right down to this one, and it says the terminal side, and terminal means stopping. So the stopping side of an angle in standard position contains the point -3, -4. Okay, so we're going to plot -3, -4. And it is this spot right here. And what I'm going to do is I'm going to connect it back to 0, 0. That's always what we do, is we connect it back there, okay? Then what we want to do is we want to make a triangle out of it. So I'm going to also connect this dot back this direction, and I'm going to make a right triangle out of it, okay? Before I move on, and before I do the 6 trig functions, which is what we're trying to do with this, find the exact value of the 6 trig functions using SOHCAHTOA, I'm going to talk about over here, right off to the side, things that are legal and things that are not legal. So here's what we do, and here is what we not do, what we don't do. We make bow ties, we do not make hourglasses. So bow tie equals good. Hourglass equals bad. We do not do this, okay? And you're like, what in the heck are you talking about, Mrs. Coventry? Here you go. Here's a bow tie, and here's how we make bow ties, all right? So if I have a dot here in this first quadrant, and I connect him back to 0, 0, as we always do, we want to connect him down this direction, okay? If we had a dot in the second quadrant, we would connect him back to 0, 0, like always, and then connect him back down this way. Okay, if we had a dot in the third quadrant, we connect him here, and then we connect him back up. And if we had a dot over here, we would connect him to 0, 0, and we would connect him up. So depending on what quadrant he is in, we always make him look like a bow tie. We do not make hourglasses, and here's what an hourglass looks like. You don't do this. This is bad. We connect him back to the x-axis, but we don't, or connect him back to 0, 0, but we don't ever connect him this direction, right? If we were over here, we would connect him. We don't ever connect him that way, right? If we were here, we would connect him. We don't connect him this direction. And if we are here, we connect him, and we don't connect him this direction. This is bad. We always want to make bow ties. We never want to make hourglasses. So this is a no-no. Don't do that. Get that out of your head. So when we had our -3, 4 in this, or -3, -4 in this quadrant, we connected him back to 0, like we always do, and we connect him up, which makes this little corner of my bow tie, not an hourglass, right? All right, and then what I want to do is I want to label my sides of this triangle. This side is going to be -3 right here. This side is -4 right here. And then what I need to do first, before I even think about doing any of this stuff over here, is to find that third side, okay? So I can do that by using the Pythagorean theorem, which is a squared plus b squared equals c squared, okay? And the side that is missing is my side c. That's my longest side, so I'm going to leave it as c squared, okay? And it doesn't really matter what your a and your b are, so let's just say a is -3 and b is -4, okay? So -3, I'm going to square that, plus -4, I square that, and when I square those negatives, they become positive. Like -3 times -3 is a positive 9, plus -4 times -4 is a positive 16, right? And 9 and 16 make 25, and when I would take the square root to find c, I find that that is just a positive 5. So 5 is this guy right here, okay? All right, now what I want to do is I want to do SOHCAHTOA and find out what just my fractions are. So SOHCAHTOA. I'm going to do just my fractions for sine, cosine, and tangent, and then we're going to flip them to do these. So don't worry about these for right now. We're going to do these three first, okay? So sine, cosine, and tangent, all right? They're going to look like fractions, so I'm going to make a fraction bar for each one of these, and let's get to labeling. So here is where angle theta lives. Okay, that's the angle that I'm focused on, is always right there in the corner. Okay, this is always my corner angle. That's where angle theta lives. So my -3, my 4, and my 5 need to be labeled. Oop. -3 and -4 and +5 need to be labeled. The opposite angle is going to be, or the opposite side is going to be -4. 5 is the hypotenuse side, because that was my side C again. And then -3 is the adjacent side, okay? So when we go to do sine, cosine, and tangent, sine is OH. So the O is -4 and the H is 5. So we would put -4 over 5. And that is what sine of theta looks like. That's all I do, right? Cosine is AH. We've done this before. It's just that like they had already given me my triangle. Now we're having to draw the triangle to start with, okay? So cosine is AH. A is -3, H is 5, so it would be -3 over 5, and that's all. Tangent is OA. O is -4, A is -3. Now, this one is a little bit more work, just because we have two negatives, so what we can do is we can cancel those off to be just 4 over 3. If you have two negatives, just make the whole thing positive, okay? And then that's pretty much the majority of the work to get from sine to cosecant. Those are like a married couple, they're like partners. And what happens is cosecant, the ratio for cosecant, flips those two. So instead of being -4 over 5, it's 5 over -4, and that's all you do. You just flip them, okay? This guy to flip would be 5 over -3. And if we flip the 4/3, we get 3/4 for cotangent, okay? So not really hard to do these three as soon as you have the other ones done, okay? So I know that we've done the SOHCAHTOA stuff before, but now we are having to draw the triangle ourselves rather than it already being given to us. And that's really the only thing that's the crazy weird part, okay? All right, last thing, because we're going to do this video or this section in two, or this section in two parts. So example 2 is the last thing I'm going to do. We're going to save the rest of this stuff for tomorrow. But example 2 has something weird that happens with it, and we're still doing the same thing again. It says the terminal side of the stopping side of an angle in standard position contains 0, 6, okay? And 0, 6 is 1, 2, 3, 4, 5, 6, just like this dot right here, okay? So like I don't even have a triangle because I don't have like anything to go off of, okay? So what kind of makes sense in my mind to do is I'm going to like cheat, and I'm going to make this a triangle that's not really a triangle. I'm going to slide this off to the side over here and make it over here. And I'm going to make just a slight triangle. But this, I'm going to pretend that this side right here is 0, right? Which really doesn't, like, means it has no width, but I'm just kind of like making something that shouldn't be a triangle into a triangle by making it have a width of 0, okay? And if I do that, then this side is 6 and this side is also 6, which is weird. Usually our hypotenuse is bigger than any of the other sides, but since this side is 0, we're like pretending that it's a triangle, right? If it helps you to do that, we can pretend that it's a triangle. So I'm putting it there, and then when I do that, my angle theta is going to be this angle right here, which means that this 6 is the opposite. We've kind of pretended that this is the hypotenuse, and then my adjacent side, adjacent side is that 0 down there below. Okay, so I'm making it into a triangle even though it's not a triangle. That just kind of helps me to see it a little bit better. So we're still doing SOHCAHTOA, SOHCAHTOA, and we've got our fractiony things over here. So fraction, fraction, fraction. Let's just do sine, cosine, and tangent first. So sine is opposite over hypotenuse, okay? And opposite hypotenuse is 6 over 6. But we're going to reduce that because 6 over 6 is just 1. So we have sine of that angle theta will be 1, which is kind of interesting. Let's do cosine. Cosine is adjacent over hypotenuse. Adjacent over hypotenuse. AH, right? Adjacent over hypotenuse is going to be 0 over 6. Okay, which is kind of weird. 0 divided by 6. Remember this. Get this stuck in your head. 0 divided by any number is going to be 0. Maybe you knew that already, but now, maybe you didn't. But if you didn't, now you know. 0 divided by any number is just 0. Tangent is opposite over adjacent. OA, opposite over adjacent. This one is 6 divided by 0. Okay, and there's a difference between 0 divided by 6 and 6 divided by 0. 6 divided by 0 is undefined. So I'm just going to put UNDEF, undefined. Okay, all right, now cosecant. If I would take and flip sign, like the flip of 1, or let's just think about like flipping these two, right? If I flip 6 and 6, it's just still going to be 6 over 6, which is still 1. So the flip, if I take 1 and I flip it, it stays 1, which is kind of interesting. Secant, though, if I take this guy and flip it, it becomes 6 over 0. So if I take 0, like the flip of 0 is actually going to be undefined because we're dividing by 0 in that case. Now, if we flip undefined, you can probably guess 6 over 0 is 0 over 6, and 0 divided by any number is 0. So when I take 0 and I flip it, I get undefined. When I take undefined and I flip it, I get 0. If I take 1 and flip it, I get 1. So kind of some weird things going on there, but if you go back to just these fractions, it's kind of easy to see, what ones are 0, what ones are undefined when you go to flip them. So a little bit weird stuff in example 2, just because we're making it into a triangle that it wasn't already there. But, hopefully that made sense, okay? The backside we're going to save for tomorrow, and the problems that I want you to do for homework are on skills practice, just 2, 4, 6, 8. You do need to draw a picture of what the angle looks like and find the hypotenuse and the 6 trig functions. So you'll write them all out as like sine, cosine, tangent, cosecant, secant, cotangent. You'll write all of those out for each one of those 4. That's a lot of problems. And then those 3 on the backside. So 1, 2, and 3 on the backside as well. So 7 problems. They were a little bit longer, but hopefully you've got the majority of the class period left to work on that. So evens 2, 4, 6, 8, and then 1, 2, 3 on the backside practice. We'll add to that tomorrow when we do some examples and finish the notes.